Okay, this is a video on the types of collisions, what those words mean, and also what equations we can use for each. Alright, we start out with elastic collisions. Next category is inelastic. And the final category is superelastic. Elastic means this is the same thing as saying KE total is conserved. The amount stays the same. Inelastic is the same thing as saying KE total decreases during the collision. And superelastic is the same as saying KE total increases. All right. Like that. 3 types. Now we do take inelastic collisions and we break it up. We say there are 2 types of those. There are types where the objects stick together. Stick together at the end or after the collision. And then there are types where they don't stick together. Don't stick together at the end. These on the left, where they stick together, we give them a fancy name. We say they're perfectly inelastic. Perfectly inelastic. We don't give a name to these over here. I mean, if you wanted, what would we call them? Imperfectly inelastic? I don't know. It's too many M's. Imperfectly, inelastic. I don't know. There's just too much going on here. We have enough terms as it is. We will leave it to this. Leave it at this. We're not going to give a name to these on the right. We're just going to say they don't stick together. But they're still inelastic. These are still inelastic. Okay, so what equations can we use for each scenario? Well, if they're elastic, we can use the big long equation UA MA UA plus MB UB equals MA VA plus MB VB. You can use that for elastic equations, collisions. You can also use this other one that I showed you, UA plus VA equals UB plus VB. Now, this equation here, we can also use for inelastic collisions where they don't stick together. Right? Because if they're not sticking together, we don't have to combine the masses together at the beginning. The masses aren't combined together at the end because they're not sticking. So this applies here as well. For perfectly inelastic collisions, they do stick together at the beginning. Right? They stick together at the end rather, at the end. So instead of writing the same equation, let me copy it over actually. Like this. At the end, there is a single final velocity, v. We could take out the subscript a and b. There's one value of the final velocity, and so we could factor that v out. We can factor it out from the 2 terms, and what we get when we do that is ma plus mb close parentheses, times the final velocity v. Okay. What about superelastic? Well, it's a similar kind of thing. The scenarios we are looking at are ones where superelastic, they start together. And if they start together, they have the same initial velocity. There's only a single u to speak of. There isn't some ua, which is different from a ub value. They're all the same. They're both the same, UA and UB. So just like before, we could factor the U out of the 2 terms. And when we do that, we get MA plus MB times U. the single initial velocity. So these are the types of collisions. These are also the equations that that we use for each. Notice that for superelastic, you can kind of think about this equation if you want, right? You just need to put the same value of u here and here for A and B. And likewise, for perfectly inelastic, you can still use this equation. You just have to remember that the two v's are the same. So this is a more complete picture.